And hello, we're going to go ahead and spend some time talking about the topic of linear motion. Okay? And there's some terms I want you to be aware of when we're talking about linear motion. These terms are rate, speed, velocity, and acceleration. Okay, rate, speed, velocity, and acceleration. Those are some words that you need to know from this. Rate is a quantity divided by time. Quantity divided by time. Okay, rate always has time with it. Okay, and we're going to get to the other ones, speed, velocity, and acceleration here in just a little bit. So for the most part for this section, we're talking the main concept that you definitely need to pay attention to is motion. Okay, we're going to be primarily talking about motion. Okay, and everything in motion, everything moves. Okay, everything moves. Even the ground moves. Okay, everything moves. Even if it appears to not move, it does move. Everything moves in respect to another object. For example, a car driving down the street is moving in respect to the building that it is passing. Okay, if we are standing still and somebody walks past us, they are moving in respect to us. Okay. Now, if we're standing still, we're still moving. We're moving in respect to the stars that are out in space. We're still moving because we're on Earth, and Earth is constantly moving. It's spinning on its axis, and it's revolving around the sun. So when we talk about speed in this section, we're primarily talking about speed of things in our environment in respect to the surface of the Earth, because motion is relative. It's all based on your perspective. So getting back to speed here, speed, okay, is a measure of how fast something is moving. How fast something's moving. Okay? Speed is always measured in terms of a unit distance. Okay? Whether that's meters, miles, kilometers, it always has a length of some kind. It has a distance. Speed always has distance. Always has distance. Okay? In addition to distance, speed also has time. So speed has distance and time. For example, I'm driving down the road at 60 miles per hour. The miles is the distance. Okay, that's the distance. And the hours, that is a rate of time. We measure time in hours. We can also measure time in minutes. We can also measure time in seconds. Those are all measures of time. So let's continue talking about speed, and there's another term that I'd like you to be aware of, and that's instantaneous speed. Instantaneous speed, okay? And instantaneous speed is the speed at any instant. Speed at, and I'm going to abbreviate it with the at symbol, at any instant. Okay? Just pick a time. I mean, at any point in time, how fast an object is moving is the instantaneous speed. Excuse me. Cars do not always travel 60 miles per hour. Their speed fluctuates anywhere from 0 up to whatever. Okay? We do not always walk slow or always walk fast. Our speed fluctuates. Speed fluctuates. So instantaneous speed is a measure of how fast an object is moving at a specific time, not overall. Now, another term we need to know is average speed. Average speed. Okay? Average speed. Now, this one's going to come with a math formula because I know we're so excited about using math all the time. But average speed, and I'll just abbreviate AVG, speed, okay? Average speed equals the total distance an object travels, okay, divided by the time traveled. Okay, so for example, Grandma leaves her house and she's traveling to your house, and the total distance it took Grandma to get to your house was 120 miles to get to your house. Okay, that's that's the distance it took to get from her house to your house. And let's say it took Grandma, let's say 2.5 hours. Okay, 2.5 hours to get there. Her average speed is the total distance, which is the 120 miles, divided by the 2.5 hours. So we can plug that into our formula, 120 miles divided by 2.5 hours, right there. And when we do some basic division there, we figure out that Grandma's average speed was 48 miles per hour. See, these two units are not the same, so miles does not cancel hours. So in the end, we're left with a rate. This was the rate, 48 miles per hour is Grandma's rate that she was traveling, average speed the whole time. She wasn't traveling 48 miles per hour when she left the stop sign, but average overall was 48 miles per hour. Grandma driving kind of slow to get to your house. So 48 miles per hour was her average speed. So let's take a moment here and let's do some practice problems. Okay, so I'm going to erase all of this and let's do some practice problems. Okay, so let's just take a second and let's try out some of these practice problems here. Question number 1. The speedometer in every car also has what's called an odometer. Okay, now an odometer is something that records the distance that a vehicle travels. Okay, if the odometer reads 0 at the beginning of a trip and 35 kilometers a half hour later, what is the average speed? So we're calculating average speed again. Okay? Take some time, use that information that I've underlined to calculate the average speed. Next, 1B. Would it be possible to attain this average speed and never exceed a reading of 70 kilometers per hour on the speedometer? And 2, if a cheetah maintained a constant speed of 25 meters per second, it will have covered 25 meters every second. At this rate, how far will it travel in 10 seconds? In 1 minute? Take a minute to work through those, and then we'll go over them together in class.